Now we are going to multiply a matrix by its identity and demonstrate that it will leave it unchanged. It will not change the original matrix. I mean, that makes sense because the identity element for the real numbers is the number 1. If you multiply any number by the number 1, it's unchanged. Okay, so yeah, we expect this to be unchanged, but there's something a little more complicated about matrices. You can multiply the matrix on the left, or you can multiply it on the right. And we usually don't get the same answer when we do that, but let's see what happens here. Okay, so we're going to take the matrix A, which is a 2-row by 3-column matrix. It has -1 down below 0, 2 down below 1, and 0 down below 3. We're going to multiply it by its identity. Now, which identity are we going to use? Right? They're not always going to be the same. They all depend on the dimensions, in this case, 2 by 3, the dimensions of the matrix. So what we're going to do is we're going to do a right multiplication by identity to this matrix, a right multiplication. Since we're going to multiply it on its right, we have to use the 3 by 3 identity. Why is that? Why do we have to choose the I sub 3? The 3 by 3 identity in order to do this right side multiplication? Because if you set it up, here's our capital A matrix at 2 by 3, and you're going to put some identity matrix. Now, the only qualification to be an identity matrix is that it has 1s on the diagonals and 0 everywhere else. That's the only qualification. But it could be a 2 by 2, a 3 by 3, a 4 by 4. It has to be a square matrix. It has to have the same number of rows as columns. All identity matrices do. But which one do we choose here? Well, we have to match the dimension by the inner dimension on the left side for the left side matrix. So we're multiplying on the right side. So the guy on the left, we have to match his inner dimension. That's why we chose 3 by 3. If he had a different inner dimension here, it would be different identity. And you'll see that when we get to part B. This is part A. Okay, so now we're set up with our 3 by 3 identity matrix. We're going to multiply on the right side, matrix A. We have equality with the inner dimensions, which is required. And now that makes us very happy. That means we can do the multiplication, and the result will be a 2 by 3 matrix. Well, it better well be a 2 by 3 matrix, because it better be exactly what we started with. The A matrix is a 2 by 3. So of course, this is going to be a 2 by 3 result. Let's check it. Now, remember how we do this. We go across the first row, distribute across the first column, and put the entry in the first upper left position. -1 times 1 plus 2 times 0 plus 0 times 0, all here. Now we'll continue with the first row, distribute it across the second column, and the entry will go here on the top row, second column. -1 times 0, 2 times 0, plus 0 times 1, that results here. Now we move down to the second row, so all of our results will go in the second row of our answer. And we're going to distribute across the first column. 0 times 1 plus 1 times 0 plus 3 times 0 gives us this. Now let's do the second row through the second column and put it down here. 0 times 0 plus 1 times 1 plus 3 times 0, right there. And finally, in this position, we're going to do the second row, distributed across the third column. 0 times 0 plus 1 times 0 plus 3 times 1. There it is. Simplify each of these entries. A, matrix A, times its identity is -1 down below 0, 2 down below 1, 0 down below 3. Oh my goodness. That is exactly matrix A. And that's exactly what we expected. So we showed that A times its identity multiplying on the right side leaves matrix A unchanged. Now let's do the multiplication by the identity on the other side. So we're going to do the A identity for a 2 by 2 of a 2 by 2 times the A. And I'm going, wait a minute. We did I sub 3 last time. We did the 3 by 3 identity matrix. Why are we doing the 2 by 2 identity matrix when we multiply on the other side? We'll write the matrix A here. And this is where our identity is going to be written. Notice that the inner dimension here, it's 2 rows by 3 columns. So the 2 rows have to match the 2 columns in the identity matrix. So the way that we decide which matrix we use when we're multiplying from the left side, not the right side, we're going to choose the one that matches the number of rows. These guys have to match. All right, they do match, so we are going to get a solution. and the dimension of the solution will be 2 rows by 3 columns. Well, again, I say it better be, because we expect to get this matrix A back when we do the multiplication. We expect the identity multiplication to leave it unchanged. So we're going to go ahead and do our multiplication and distribution. You can go through and see it here. And the result is -1 down below 0, 2 down below 1, 0 down below 3. It's a 2 by 3. That is exactly matrix A. So it worked again. But the really amazing thing is it has a different identity matrix, all contingent upon which side you multiply the matrix by. It's super easy to figure out which one it is because the inner dimensions have to match. That's the key.